Hello, and thank you for tuning in. My name is Allison, and I'm here at Arizona Science Center, and I'm in the second floor Charged Up exhibit, because today we are going to be talking about electricity and magnetism. So I'm with our exhibit here, our Dancing Iron Dust Trees exhibit. So if you want to come a little closer, we have our dancing iron dust trees. You can see them moving just a little bit already. And these dust trees are very special dust trees because they are choreographed, they're programmed to respond to music. So right now you can see that they're all beginning to move. So the dust-like looking part are pieces of iron, so small pieces of iron, and underneath them are magnets. And so these iron pieces are going to be responding to the signal sent to the magnets on if they should be turned on or off. And we'll get to that part a little bit later. Essentially, some basic principles of electromagnets. These are not permanent magnets underneath those. These are actually magnets created through electricity, which is how we're able to program these iron dust trees to move. Now, when we're talking about magnets, you guys might know of magnets as things you have on your refrigerator, things that you stick that piece of art or that great graded paper up on your fridge when you come home. So magnets are really neat because we're going to come over here real quick. I'm going to show you a little bit about how magnets work. So we have just a basic bar magnet. So magnets have a north pole and a south pole. And what's really neat is I'm going to be able to show that to you all using some small pieces of iron. So these are iron filings, just a standard bottle of iron filings. They are very similar to that iron that you're going to see on those dust trees. This is just a little bit smaller so we can see things a little bit clearer. So I put a paper plate on top of this magnet, and I'm going to shake my iron filings kind of slowly onto the magnet. And what do you begin to see? So what you might be noticing is you're beginning to see these lines. So these magnetic filings are actually allowing us to see the magnetic field around a magnet. So the way that a magnet works is it has this magnetic field around it, and it's able to attract in things that are inside of its magnetic field. We know opposites attract. When we have a south pole and a north pole, those are going to be opposite magnetic forces. So when you see on this on the iron filings, you can see these two poles, the north pole and the south pole. And you can start to see this magnetic field in these loops. So we said that opposites attract. So the north pole and the south pole, they're going to be attracted to each other. And you can see this happening with these magnetic filings as you're seeing these rings forming. Now, if you have iron filings at home and a bar magnet, you're able to see this. Those round magnets that you stick to your fridge, you can't see these magnetic fields in the same way because oftentimes the side you stick to the fridge would be the north or the south pole, and the other side would be the opposite. So it's a little harder to lay out and see these fields forming. So this is how permanent magnets work. They have this permanent magnetic field around them, and things inside that magnetic field are going to be attracted to them. That being said, are all things magnetic? Will everything be attracted to this magnet? Am I going to stick to a magnet? No. So I am not magnetic, so I'm not going to stick to a magnet, but something metal, like a paperclip, will be attracted to this magnet and will stick to it. Now, when we're looking at magnets, if the magnet was a permanent magnet inside our exhibit, the iron filings, like the ones here, they're not moving. They're stuck to it permanently. That magnetic field is always around the magnet. Now, with the dancing iron dust trees, we want them to be able to move, which means we need to turn the magnet on and off, which you can't do with a permanent magnet. What you can do it with is an electromagnet. So you're actually able to make an electromagnetic comb. And what happens is as electricity flows through a wire, it's going to create a magnetic field. So in this case, I took some wire, some copper wire that I had, and I wound it really tightly around a nail. So you can see lots and lots of loops all the way around, just a standard nail. Then when I connect this to a battery, electricity is going to start flowing through it. So this electricity is flowing from one end of the battery to the other, this current electricity. And as it's flowing through, it's going around and around and around and around and around and around and around. And as it goes around, it's going to create a magnetic field. And since these are so tightly bound together, this magnetic field is actually going to start to encompass this nail. And it's going to create, just like we saw here with this magnetic field, A magnetic field similar is being created through this nail because of the wires. So I can use this to actually pick up, oops, let's use my right hand. I can use this to actually pick up a paperclip because this nail is now a magnet. So it's not, fastened or anything, it's just stuck to the bottom. But if I were to stop this connection, the magnet, it's not a magnet anymore, and the paperclip will fall right off. Just like these dancing dust trees, when the electricity is disconnected to that magnet, the iron filings are going to fall right off. So this is just the basic version of electromagnetism and magnetism. So thank you all for joining us today and exploring our dancing iron dust trees exhibit.